Hi and welcome to our pre-calculus. The topic today is half angle identities problem type 2. So we have gone through a set of exercises with respect to using half angle formulas. We looked at case of degrees, case of radians, and in those problems we had a specific angle given to us and we find its trig functions. Now, the type of problems that you come across, you see that a trig function of the angle is given, the quadrant information is also given, the quadrant is also given, and what we are after is a trig function of half of that angle. So, very similar to problems we had before, and so we should be good to go. As a reminder, we had the formulas for sine of half angle, cosine of half angle, tangent of half angle. The plus or minus in front of them is decided by type of function and the quadrant of the original angle, the one that you are calculating. With respect to tangent, we had two additional formulas that didn't have a radical and also didn't have the plus or minus in them, and therefore gave us some advantages. Let's go ahead, take a look at this one. So we have an angle alpha. Here, this tells us the angle between pi over 2 and pi. It means alpha is in quadrant 2. Okay, between pi over 2 and pi, therefore it's in quadrant 2. What are we given? We are given that its tangent is minus 2/3. So here is some representative angle in second quadrant. So this is our alpha. What we remember, tangent of alpha was a ratio of y over x. Is that right? Y over x was tangent of alpha. So which one of them is going to be negative? I'm in the second quadrant, so y has to be positive, so I just write y is 2, and x better be negative, so x is minus 3. And there, so this is my y, this is my x. R is always given by a Pythagorean formula and it's always positive. So radical minus 3 squared and 2 squared, so that is going to be 13. So this is radical 13. Okay, now I have everything I need to know about alpha. I want to go after alpha over 2. I will use the formulas that we have there. We might as well go ahead and calculate cosine of alpha. Why do I need cosine of alpha? Because in all these formulas, cosine is used. If I want to use these formulas, I also need sine. So if you want to go ahead and calculate sine as well, it's up to you. So cosine of alpha, cosine is the ratio of adjacent to hypotenuse. So adjacent is minus 3 or x. So let's remind ourselves cosine of alpha was x over r. So x is minus 3, r is radical 13. So now I am ready to go. So suppose you want cosine, so let's go after cosine of alpha over 2. What did we know? It's plus or minus 1 plus cosine of alpha over 2. How do we decide this? We decided by where this one is. Well, where is alpha over 2? Alpha is in second quadrant. Half of that is going to be in the first quadrant. So alpha over 2 is in quadrant 1. So when I want to write cosine of alpha over 2, I know it has to be positive. Positive of 1 plus cosine of alpha. Here's my cosine of alpha, minus 3 over radical 13. The whole thing divided by 2. Now, your software will accept this thing as it is, and you could say the problem is already done. If you want to clean it up, there are various things you can do, like multiply by radical 13, so it becomes radical 13 minus 3 over 2 radical 13. Okay, so let me again emphasize. Here you can say the problem is finished, but if you want to continue, practice some of the old stuff, one thing we can do is to multiply by radical 13, so it becomes 13 minus 3 radical 13. So I multiply this by radical, so it comes out of radical. This becomes 3 times radical. Multiply this by radical, also becomes radical 13 times radical 13. 13 just comes out, times 2 becomes 26. So if you want to say this thing is easier than, simpler than beginning or not, well, that could be debated, but you can go simplify even further, but let's declare the problem done at this stage. What else? We have to calculate tangent of alpha over 2. Tangent of alpha over 2. What else do we need? Well, let's say I want to use this formula. I need sine as well. So let's go ahead and say sine of alpha. What is sine of alpha? You remember sine of alpha was y over r. So in this problem, y is 2 and r is radical 13. And then tangent of alpha over 2 was sine of alpha over 1 plus cosine of alpha. Okay, let's just to be sure, this is sine of alpha over 1 plus cosine of alpha. So I can say sine of alpha is 2 over radical 13. 1 cosine of alpha is minus 3 over radical 13. Multiply by radical 13, you say 2 over radical 13 minus 3. Okay, so and again, your software would have accepted this, but it just takes a little bit of effort. We might as well spend it to make it look like this. And if you want to multiply and apply rationalization, here you can go one more step. So let me do it just in case some of you have already done this thing. And so 2 times radical 13 plus 3. So it's just algebra practice. Radical 13 times radical 13 is, well, of course, 13 minus 9 is 4. Simplify one more step. Radical 13 plus 3 over 2. Okay, so that was the story of tangent. All the rest of these problems are similar. Here, problem is giving the angle alpha to be in quadrant 4. Is that right? Between 3 pi over 2 and 2 pi. So we have an angle looking like this. We are opening all the way between 3 pi over 2 well, let's point out what happens to alpha over 2. Alpha over 2, just divide everything by 2, becomes between 3 pi over 4 and pi. Alpha over 2, somewhere there. So all we need to know about it is that we are in quadrant 2. So let's go after the first one, sine of alpha over 2. I know in the second quadrant I'm positive, and my formula is 1 minus cosine of alpha over 2. That's what I want to use. Well, what is cosine of alpha? We go back to information that is given. We are given that cosecant of alpha is minus radical 10 over 3. What is cosecant? We haven't seen this friend for a very long time. That was just 1 over sine of alpha. That's what cosecant is. So that's minus radical 10 over 3. Let's make it look like a more familiar creature. Minus 3 over radical 10. We remind ourselves sine was y over r. So if I'm here at coordinates x, y, and distance r, here is my y and here is my r. So it makes sense to take y to be minus 3 and r to be radical 10. So if this is radical 10 and this is minus 3, what is left for x? Of course, x has to be 1. Is that right? So x is 1 because y squared plus x squared has to be r squared. So x has to be 1. Now what? Well, we have sine of alpha. Sine of alpha is minus 3 over radical 10. How about cosine of alpha? Cosine of alpha is x over r. That's 1 over radical 10. Notice it is positive. We are in the first quadrant. You can get tangent also out of it, but that's we don't have much use for that. So all told, sine of alpha over 2 is 1 minus cosine of alpha, 1 over radical 10 over 2 multiplied by radical 10. So again, your software will be happy if you just stop at any of these places. If you want to do some algebra practice, here's the practice. I multiply by radical 10. That's what I get. I can multiply by radical 10 again, and that's going to become radical 10 times radical 10 is just 10 minus radical 10, and denominator radical 10 times another radical 10 is 10 times 2 is 20, and then we are done. Well, how about tangent? Several options. One is to go ahead and calculate cosine of alpha over 2 and take a ratio, or we can just go straight to tangent of alpha over 2 is sine of alpha over 1 plus cosine of alpha. Is that right? Tangent. Again, we are using this formula, sine over 1 plus cosine. So sine minus 3 over radical 10 over 1 plus cosine 1 over radical 10 multiplied by radical 10, it becomes minus 3, and I get radical 10 plus 1. And we check the answers. Does it have the appropriate sign? We are in the second quadrant. Our tangent has to be negative, and that looks okay. Okay, let's go to another one. We are in angle theta. Theta is in quadrant 2. So we have a picture looking like this. We just draw some random angle in quadrant 2. That is the theta we are dealing with. Obviously then the theta over 2 is going to be in quadrant 1. So all of its trig values will be positive. Here we pick a point here, call it point xy, meaning this is my y and this is my x and this is my r. Sine is given. Sine is a ratio, so sine of theta is y over r, and that is going to be 4 over 5. And x becomes minus 3. Is that right? Everybody with me there? The triangle is 3, 4, 5, but we're on the left side, so x is minus 3. So what does that give me? It gives me that cosine of theta is minus 3/5. Now, if I want to get cosine of half of this angle, I use, first of all, it's positive because in the first quadrant. Then 1 plus cosine of theta over 2, sorry, uh, and then so is plus 1 minus 3/5 over 2. This becomes, so we better clean this up, otherwise we are going to look strange. So this becomes 2 and this is 2. They cancel each other out and we get radical 1/5. And that's good. You can write it as radical 5 over 5 if you wish. How about tangent? Tangent of theta over 2. Again, sine of theta over 1 plus cosine of theta. So my sine is, well, sine is given to me, is 4/5. Cosine is minus 3/5. So this becomes 4/5 over, this is 2/5. And that's going to be 2. And then we are done. So one more of these things if you needed one more. Alpha is in second quadrant. So we have a picture like this. We are in the second quadrant again. Secant is minus radical. Secant of alpha is minus radical 10. Well, what does that mean? It means cosine of alpha is minus 1 over radical 10. It's a reciprocal of this. Cosine is the ratio of x over r. So if this is a point with coordinate x, y, of course this is a y, this is x, and this is r. X has to be minus 1, r has to be radical 10. And what does that leave for y? What is going to be the value of y? Y is going to be, of course, 3. So all I need to perhaps figure out here is sine of alpha is going to be y over r, and that's going to be 3 over radical 10. So I have my sine and I have my cosine. First thing is cosine of alpha over 2. Again, if alpha is in quadrant 2, half of it will be in quadrant 1. So that tells me I start with a plus, and then 1 plus cosine of alpha over 2, and that is 1 plus okay. So again, your software is happy at this stage. If you want to practice a bit of algebra in order to get ready for your calculus classes, so you can do multiply by radical 10, and then you have 2 radical 10, multiply by another radical 10 if you care for that, becomes 10 minus radical 10 over 20. You can simplify further, but that is good enough for us. How about tangent of alpha over 2? Again, let's write sine of alpha over 1 plus cosine of alpha. We could have used the formula with the radical as well. Then you'll have more radical inside radical. So perhaps this is a bit cleaner. Sine of alpha is 3 radical 10. Cosine is 1 minus 1 radical 10. And you could stop there, or if you want to continue, multiply by radical 10, multiply by the conjugate if you wish, 3 times radical 10 plus 1, and product of these two will be what? 9, of course. And then you get radical 10 plus 1 over 3. So from here to here, any of these answers, any of these 4 answers will be good. The last of them is the preferred style. Okay, we have looked at this thing in so many different angles, excuse the pun, and so we should be good to go with this half angle identities. They get to be used in integration problems quite often, and that is going to come up in calculus 2. So we are kind of far away from that, but we are getting some practice. Okay, until then, good luck and God bless.